Okay, we're going to tackle now time zones, and I would love you to try and understand this because it's so fascinating and so applicable to everyday life, with everybody traveling overseas and everybody having family members, and it's very important for you to really understand this concept. I'm going to try and explain this as best as I can, and if you need to, you might need to ask your teacher to explain it to you even further. We're going to consider this is the Earth and it's round. Okay, so if the sun is up here from the top, or let's make this the sun is there, the Earth is rotating around its own axis. Okay, and the sun, remember, the sun is standing still, and we're going to rotate around the sun, but we're only also rotating here. So when I rotate around my axis, I can see that that causes night and day, because this will be closer to the sun, that will be then closer to the sun during the day, and it will be night at the back. So day, night, the closest part to the sun, that is where it's day, the other side is night. What we've done then is we took this Earth that rotates around its axis in 24 hours, and we drew a line. Now, the line that we're going to start off with is the line, because this is rotating, at some stage we need to say the day is starting now at this stage. So at a certain point, now because the Earth is round, it could have been anywhere. So what they did is they make right in the middle, so right this line, we call that the international date line. And the international date line is when the new day starts and the old day ended. Let's just move it like this. New day ended, start, old day is still on. So everything on this side is still on. I'm also going to show you then, what we did then is we divided this. Now this is the North Pole. This is going to be the North Pole. Right, and this is going to be the South Pole. Now, this will be 180 degrees. If I draw lines right around, that will give us an angle of 90 degrees. That difference there is then 90 degrees. If I do this 24 times, because there's 24 hours, we're going to have 24 of these lines that looks like this. Okay, and they are, each one of them will be then 15 degrees apart. Because there's 360 degrees in a circle, there's 24 of these days, so each one of these angles are 15 degrees apart, and that comes from the angle that I measure there. So it's the angle measured will give us that. Now if I take this, and because it's very hard to draw an Earth like this, we're going to flatten this, okay, with the international date line on the end. And what we're going to do is we're going to make 0 right in the middle, which goes through the United Kingdom, through a little town called Greenwich. And that Greenwich meridian is then the line that they call this. So this 0 line is called GMT, Greenwich Mean Time. GMT, Greenwich Mean Time, or they also called about the Universal Timeline, UTC. Coordinated Universal Time. That starts at this 0, so right in the bang smack in the middle there. Okay, so on my Earth, there it is. I flatten it out. Now what you have to realize is, because we flatten it out, the only place where these lines are exactly apart, 15 the same distance, will be here. If I want to redraw this, these lines will all have to go in towards the top and towards the bottom. Okay, and that is why if you're on the equator, which is around the middle here, if you're on the equator, the days, the sun will have to travel in 15 degrees. In 1 hour, the sun is traveling much further than up here at the North Pole. Because in an hour, the sun is only traveling that bit. It looks like it's only traveling that bit. So if the sun is here, these guys are going to see the sun move through the air much quicker than the people there. That's why when you're at the North Pole or closer to the North Pole, it looks like the sun is standing still, because it's moving in a small time, in a long time, a very small distance. Okay, although there's still an hour difference, you can't see it according to the sun. Okay, so we flatten this out. And what we then say is between each one of these lines, there is an hour. And that's where our time zones come in. Greenwich Mean Time is right in the middle. Now, I can't make the paper move. I'm going to make the sun move, although we know that the sun is actually standing still and the earth is moving. So in the east, this is north, east, south, west. Oh, I'm missing that now, north. The sun comes up in the east. So the day starts when it crosses the international date line. Actually, it's happening at midnight when the sun is still on the other side. But these guys will have day first, which means they are always ahead of time. If this is Greenwich, if this is midday, the sun is right in smack center middle. Okay? These guys already had the day. If this is 12 noon, right in the middle of the day, these guys here already had, so they are plus, and that is why we put the times there. So this is Greenwich Mean Time, and all of these times on this side is plus, just like a number line. If it's 12 here, for everybody on this side of that timeline, it will be plus 1 hour. So it will be already 12 noon, this will be 1 o'clock p.m., 2 o'clock p.m., 3 p.m., 4 p.m., 5 p.m., 6, 7, 8 p.m., 9 p.m., 10 p.m. So in Australia, 10 p.m., we fall in this category. We are already 1 hour, we're already 10 o'clock at night. These guys is then exactly in the middle. These people on this side is behind. So if this is 12 noon, the sun must still reach them. So you're going to subtract. So this is plus and the red is negative, which means they still have to get, they are behind in time. The sun still needs to get there. So if this is 12 noon in the middle, on this side, we're going to have subtract. We're going to go minus. So it's 12 noon here. This is going to be 11 a.m., 10 a.m., 9 8 a.m., 7, 6, 5, 4, 3, 2, 1 a.m., all the way to the down there, 1 a.m., and then the international date line, which meets up here. If you go over the national date line, you'll go into the next day. Okay, and that is how the dates then work. That is how this map works. So all you have to remember is that the values on this side is whatever it is plus, the time difference is plus in this direction, minus in that direction. So if I go to any, let's go to Sydney, and Sydney is over here. If I go to Sydney, which is at plus 10, and we want to know what is the time in Johannesburg, and Johannesburg is over there. They are at plus 2. They are plus 10 plus 2. They already had the time. If I go in this direction, here, this direction will be, doesn't matter which direction, will be minus, and in that direction it will be plus. So if I go from, if I have the time in Sydney and I want to know what's the time in Johannesburg, it means it is negative, and the difference between these two, 10 and 2, is 8. So the difference between them will be 8 hours. 8 hours earlier because they are the latest possible time. If we say between Sydney and let's say Los Angeles, we are plus 10, they minus 8. The difference between the two is a full 18 hours. It's 10 this way and 8 that way, so it's an 18-hour difference. They are to the right of this, so Los Angeles will be 18 hours behind whatever it is here. Okay, we are never going to, for calculations, we never cross the international date line. We always have the international date line on the side. We never cross that. We always work away from the international date line. If I want to know what's the difference between, let's say, Lima and Peru, and let's go to can't even read this so small, in Perth. Okay, Peru is at 5, Perth is at 8.